Hello again, geometry. Here we go with lesson 2 in unit 1. So with lesson 2, we're going to name and define segments and rays, and then differentiate between differing types of non-intersecting lines and planes. So here we go. A segment is what you're more used to here. We did a line in the first lesson, and you really don't see very many actual lines that go on forever. Okay, you're used to seeing segments. A segment is a part of a line, okay, consisting of two endpoints and all the points in between. Okay, name all the segments on line K below. So FG is one of them, and it's just a bar over it. GH is another one. We'll stop there. Nope, I got one more. FH. Okay. Could I flip them? Yes, I could say GF, HG, HF, but those would be the same. So there's actually three segments here. How many points are on segment FH? Don't say one, don't say three. There's actually an infinite number of points on segment FH, just like there's an infinite number of points on FG, just like there's an infinite number of points on GH. Remember, a point has no size. There's three labeled points on this line, but I just said how many points. There's an infinite number, okay? Next part, so we just talked about segments. A ray is a part of a line consisting of one endpoint and all the points of the line on one side of that endpoint. Okay, and to go along with a ray, we have some things called opposite rays. And opposite rays have two parts to the definition. Okay, they are two, and this is the first part, collinear rays. Talk about that in a second, with the same endpoint. So first of all, let me do this. These always form a line. Opposite rays always form a line. So two parts of the definition for opposite rays. Part one, they have to be collinear, which is where that last part comes in. They have to form a line. So together, the two rays would form a line. And the second thing is they have to have the same endpoint. That's the one that gets people a lot, is that part of the definition. And I'll show you that here in a little bit. Okay. Name one ray with endpoint C. So C is right here. Any ray with endpoint C would just mean I'm starting at C and going and literally right any of the other labeled points. So CF. And I would put an arrow in it. Your arrows are always going to the right. Okay. Don't have them going to the left. It's just, we don't do that. Okay. CB would work, CA would work, CD would work. Okay, I'm going to clear all that. Are BD and BC the same ray? And explain. So BD, the first letter always names where it starts. The second letter gives direction. So D is on that side, so it's that way. So BD is that blue ray there. BC starts at B and goes towards C. Are those the same ray? Yes, they are. Why? They have the same endpoint and go in the same direction. Okay, so they are the same ray here. Are AB and BA the same ray? Well, people think, oh, cool, they just flip. So yes. Well, let's look at it. AB, so start at A and go towards B. Switch colors. Now BA, I start at B and go towards A. Are those the same? No, they are not. They have different endpoints, right? Now the definition says endpoints. I've been using the word starting point. So in this, Endpoints means essentially starting point. Okay. It's weird, I know, but yeah, endpoint and starting point basically mean the same thing. All right, our CD and DB opposite rays. So CD, so start at C, go towards D, and then DB, so start at D and go towards B. Are those opposite rays? Well, they form a line, right? If I put the blue and the red together, I got a line going on forever in both directions. But remember, there's two parts to the definition. They have different endpoints. If they have different endpoints, they are not opposite rays, even if they form a line. Okay. Number 4, this is usually a little bit easier for people to see, are CB and CF opposite rays. So CB, so C goes towards B, and CF starts at C and goes towards F. Are they opposite rays? No, they're not. They don't form a line. They have the same endpoint, but they don't form a line. Okay. To the back. Non-intersecting lines. So if they intersect, if lines intersect, they intersect at a point. That was lesson 1. What happens if they don't? Well, there are 2 types of lines that do not intersect. Their difference lies in whether or not the lines lie in the same plane. Parallel lines you've heard of. Parallel lines are coplanar lines that do not intersect. So 2 lines that lie in the same plane that do not intersect. Okay, if you're thinking of your room, look to your left. The wall that you're looking at, any 2 lines that don't meet would be coplanar, therefore they would be parallel. Okay. Skew lines. Okay, skew lines are non-coplanar. These are harder to picture. You've probably never seen or knew that you were looking at skew lines. To visualize this type of line, I'm gonna try to use the area that we live in to show you. So Illinois Road, I'm gonna draw a map here. So Illinois Road goes east and west. I'm gonna try that again. That's not very straight. Okay, so this is Illinois Road. This is Scott Road. All right, here's Kroger over here. You got Burger King. You've got these shops. You got a church right here. Okay. Then over here, you've got Jefferson Point, way down here, all these shops in between. But right here is I-69, right? And I-69 goes right underneath Illinois Road. They don't intersect. If they intersected there, you would have a lot of collisions. It would not be a good thing. They don't intersect, but they're also not parallel, because if they were parallel, I-69 would have to be going east and west, just like Illinois Road. That would make them parallel. But I-69 at that point right there is going north and south. So if they were on the same plane, they would intersect, but they're not on the same plane. Therefore, they don't intersect. Therefore, they're skew. All right. If that still isn't hard, you still have a hard time picturing that, let's talk in class. Make sure you put a little note here and I can try and show you. All right. Okay. Planes can also be non-intersecting. They are called parallel planes. Notice that there are no skew planes. All right, there's only parallel planes. So we got a figure here. We're gonna do some answering of questions. Name all lines parallel to CB. So CB is right here. So I want a line that doesn't intersect with CB, but lies in the same plane as CB. Well, CB lies on that kind of that tent-like thing on the right-hand side. What other line is on the right-hand side that doesn't intersect? Well, that would be EF. Name all lines parallel to AD. So I'm going to switch colors here. AD is along that back side, and it's also along the bottom, right? So it's on 2 different planes there. I guess I should go back to the blue. BC is also on the front of the figure. Is there any line on the front of the figure, though, that is parallel to BC? No, there's not. That's why EF, there's only one answer. With number 2, there's 2 answers because AD is on the left and on the bottom. On the left-hand side, there is a line that doesn't intersect AD, and that would be BE. When I'm talking about lines in the same plane, that's because I'm asking for parallel, right? AD is also on the plane that represents the bottom. AD does not intersect with CF. CF and AD are on the same plane, therefore they are parallel. This one has 2 answers. I'm gonna go ahead and clear all that. Now we're gonna look at skew. Name a line, any line, skew to BE. So BE is right here. So CF is not skew because CF would be parallel. AD is not skew because AD would be parallel. EF is not skew because that intersects, right? Those two intersect at E, so not that one. Okay, what I'm looking for is a line that doesn't hit BE, but also is on a different plane. So BE is on the left and the right part of the tent. It's not on the bottom. Are there any lines on the bottom that do not intersect BE? There's no drawn lines, right? So the only things on the bottom are well, I guess there are AC, sorry, kind of confusing here, and FD. Would you agree that those are on the bottom and don't intersect BE? So those would be 2 lines that are skew to BE. Now, I only wanted one, but I just showed you both. Okay. All right. Describe the intersection of CF and ED. So remember, 2 letters names a line and a line. If I have 2 lines that meet, they intersect at a point. If they don't intersect, they could be skew or parallel. So now we've got a little more options here. So CF and ED. So ED is here. Do those intersect? They do not. So now are they parallel or are they skew? Well, do they lie on the same plane? CF is on the bottom and on the right. ED is on the left and the back. They do not share a plane, therefore these are skew. All right. Name a pair of parallel planes. Well, there's only 2 parallel planes, and that would be the front and the back. It takes 3 letters to name a plane, so I have to use all 3 letters, so A, B, C, and D, E, F. Those are parallel planes. Okay, last one, kind of going back to the first lesson. Where do CFD, so CFD, what plane am I talking about there? That's the bottom of the tent. What's the 4th point? That would be CFD and A. And then EBA. So I'm going to change colors. E, B, A. Where am I talking? I'm talking the back, the left side of the tent. What's the 4th point? D. So E, B, A, D. I have 2 planes intersecting. If you remember that when you have 2 planes intersecting, they make a line. So I should have 2 letters in common. You should see that it is a D. Okay. Another set of questions for a new picture. Name the plane parallel to JAG. So JAG, I'm talking about the left-hand side. So what's parallel to JAG would be the right-hand side. So this side over here. So any 3 letters on there would be correct. So B, C, H. And if you want the 4th point, I. All right. So there's that one. Name all lines parallel to BC. Well, BC is on 2 different planes, right? 2 different drawn planes. So BC is on the right-hand side. And what's on the right-hand side that doesn't touch it? HI. It's also on the front. So BC, what doesn't touch BC? AD. Now, this one, last one's a little tricky. I know there's not a line, plane through the middle, but I could draw one, right? which means GJ, also vertical, is technically parallel. So GJ is also parallel to BC. Okay. Name all lines skew to BC. So we're sticking with BC. So now I'm looking for something that's not on the same plane. So the answer to this one cannot be on that plane. So that plane's out. It cannot be on the front. So it has to be either on the bottom or on the top or on the left or on the back. So we're looking for lines that do not intersect BC that are on one of those planes. So AG and DJ. You also have GH and JI. You have 4 lines there that are skew. So I'll name all those. So AG, DJ, GH, and JI. So there's 4 lines skew to BC. Name all lines parallel to GHA. Now this is a little tricky. GHA is a plane, right? 3 letters, GHA. So that's the top of the box. All lines parallel to that would be on the bottom, right? If it's going to be parallel to the top, it's got to be on the bottom. And really, any line on the bottom is going to be parallel to the top. So JD, JI, DC, and CI. All 4 of those lines are parallel to the top. Okay, and that is lesson 2.